Right. My name is Ola Leifler. I work at Linköping University together with Christian and previously Azim. And what I'm going to present briefly is a way to do requirements engineering inspired by colleagues of mine, and I'm trying to adopt their methods. And I'd like to pitch some ideas, present a case from a paper a few years ago, just to see if this is something that would be interesting for software center companies. I work together with colleagues in a group that hosts sustainabilitydesign.org, the Karlskrona Manifesto on Sustainability Design, exploring ways in which we can produce software that have the long-term effects that we would like and avoid the kind of consequences we might sometimes see. First, I'd like to give just some brief motivation to the topic at hand. Some of you might go by train. Some might have experienced what SJR, National Railway Operator, has been experiencing since October, November. They launched a new staff planning system, and ever since, in October, November, there have been cancellations, staff shortages, up to 70 canceled trains a day, up from prior 30 cancellations. And this is from February. The previous news clip was from November. So this has been a very long-running problem for them, where their new staff planning system doesn't seem to be able to present working schedules. And some have attributed this to the way, not just being a glitch, but the way in which this system was conceived and requirements were formulated, and the effects sought after. Some write about how these kinds of systems, modern staff planning systems, have as a purpose to optimize schedules, but such purposes can backfire. And some have indicated that maybe the indicator for success, maybe the decision makers, maybe those who considered legitimate in providing knowledge to this project, have all been inadequate in one sense or another. Well, there is a Swedish book written by IT consultant Jonas Söderström, who's summarized much of what people can experience at work. And unfortunately, the recent SJ example is but one of several examples of IT systems that affect staff in all walks of modern digitized life. One of his examples concern emergency services, rescue workers, police, firefighters, who, among all the stressors in their work, list IT systems as by far the most stressful for them. And so in light of this, there seems to be room for improvement. Yeah, one of the most important books written about IT systems and the problems they can bring. Now, I'll not focus so much on all the problems, symptoms, and causes, though there's definitely room to explore causes more. But I'll talk more in this session about a framework to do things differently in requirements engineering. And as I promised, I'll be basing this talk on a paper. The specific paper is called Critical Requirements Engineering in Practice. And in it, some colleagues of mine present a way to work with requirements that combines traditional Valera maps seen in requirements engineering with techniques from social science, and in particular, critical systems heuristics. Critical system heuristics originates from social planning, where in city planning, approaches in the 50s or 60s that focused very much on hard signs, measurable indicators, and rather narrow scopes for what a system should be like, were criticized. One notable example was when a bridge was constructed for, or a bridge and a passageway under, to a popular beach in close to New York or New Jersey, where it was not possible to pass under this bridge via bus. And so those who could primarily use this passageway to the beach were people going by car. And so this was effectively a way to prevent people of lesser means from accessing beaches because they were simply not in scope for the system, the bridge and the infrastructure constructed. Now, ever since, critical system heuristics has been adopted in various settings, though it's from a different branch than we're used to. So in this paper, the authors try to reconcile the concerns that are normally seen in requirements engineering to the left and in critical systems heuristic to the right. You may be familiar with the concerns to the left, the notions of stakeholders, goals, features, trade-offs, qualities, and constraints. However, to the right, there's a set of critical questions to be asked, and that complements requirements engineering in its, well, some would say, an ability to bring up power relations and politics. Who gets to go under a bridge? Who is supposed to use a system? How important is it to optimize for low-cost staff schedules versus adherence to union norms or so for SG staff? And so to the right, the critical system heuristics or critical systems theory contains a number of notions such as boundary judgments. Where is it that our intended system ends and something else begins? Values, an organization we cannot change or whatever. What about marginalization? Who's led to voice their opinions and who is effectively silenced by the way that we include or choose stakeholders? Now, these notions are typically not included in requirements engineering traditionally, and there is a map I'd like to show you with 12 or 24 different kind of questions. I'll give you examples of what these questions are and how they can be used. Now, this table is at the core of using critical system heuristics for augmenting requirements engineering. In this, we see 4 sources of influence. The first concerns how we motivate a system. There we can ask questions such as who is or ought to be the intended beneficiary of S. If it's the staff planning system of SJ, is it primarily to the benefit of train drivers and staff that we produce the system, or is it for someone else? Now, again, concerning motivation, we can consider a general purpose, such as to have trains running on time more often, having staff that are happy, having ability to attract high quality, competent co-workers, for instance, and some key performance indicators that are our measures of success or improvement. Now, some of these questions might feel familiar, some might feel less so. The last row, for instance, concerns legitimacy, where it's explicitly asked, how can we bring in those who may be negatively affected, those who are not directly part of decision-making, whose expertise is not primarily sought after in design, but who might be affected nonetheless. And how might we have different views on what is actually important, or how we should conceive of this type of problem. So these questions are at the core of asking critical, asking critical questions in design and requirements engineering. And I'll give an example of how this can be applied. The example in the paper is for a system called Home Sound. It's intended to provide elderly with a system where acoustic deviations are detected in your home, as in if you're falling in the bathroom and you try to call for help and somehow you can't reach out to anyone or you can't reach the phone, then this system is supposed to activate a call to your next of kin or to healthcare workers or so. Now, that's the idea. But we come into this system in the design or requirement stage where we've made a partial map. We've filled out the first row by speaking to a requirements engineer. The elderly should be the primary beneficiaries of the system, and we'd like them to have more independence, be able to stay in their home for longer. And in order to measure success, a number of years living at home might be such a performance indicator. Here, the source of knowledge is primarily the requirements engineer based on his or her prior knowledge of the system and the development process. And you might also understand the number of distress calls from care workers to be something you'd like to reduce as an indication that people are living well at home. Now, this map is then iterated. That's the key to use in critical system heuristics, in that a requirements engineering might have his or her view, but if we include as source of knowledge the notes from prior meetings with all the stakeholders, we find that families, the healthcare system, should also be beneficiaries. And families would like to have peace of mind that their next of kin are managing themselves well enough at home. But based on this, we might wish to understand, what about those who understand conditions for elderly, like social workers or psychologists? If we were to include them as additional sources of knowledge. In this example, they were rather critical and would like to revise the idea that number of years living at home and number of distressed calls received would actually be fair indicators of that which is claimed to be the primary purpose, namely independence. Their view was these key problems concerned security rather than independence. And the next stage in applying, in searching for sources of knowledge that could complement this picture, was to have a philosopher on board who actually get to ask, what about autonomy and self-determination? Is that really what we mean by independence? If so, then is really staying in your own home longer the best way to frame what that purpose could be? So maybe the idea that you're striving for autonomy and self-determination might in turn mean something else than what peace of mind for families would mean. Maybe those are two different views on aging, as in should the elderly be more in control, or should families get to monitor the status of their next of kin? Those are different worldviews, not necessarily reconcilable, and should be lifted up front for the different stakeholders to discuss. And also, as a potentially problematic source of control, is it possible that some who get to commodify data, or would like to commodify the data from recordings, gets to be a stakeholder? The philosopher in this case argued strongly against that. And finally, they reached out to an IT security expert who noted that this particular type of system might not be the best suited for the concern listed, and would like to include as an additional key problem to address, the number of potential vulnerabilities during a security audit. And so would like to add additional metrics in order to determine whether the system would be a success. Now, what you'll see here is only a partial map, and what we began with was only a partial map. And the idea is not to start with an empty map and end with a complete one, but rather to use this heuristic, as in these different types of questions to guide a critical mindset in reviewing requirements, including new sources of knowledge. I've listed a few sources of knowledge, but that's by no means an exclusionary list. And for more information about specifics, I mentioned that this can be seen as complementary to using Valeria maps and similar material seen in requirements engineering. If you go to sustainabilitydesign.org and click to publications, you'll see at the bottom a list of materials and templates, including mappings between the Valeria maps typically used in Valeria templates typically used in requirements engineering, and the ideal map that I presented some iterations of. And so that, along with the paper, is the starting point that we're using for some projects with students. And I'm very curious to learn if you find requirements engineering to be something you'd like to look closer at, and potentially with a tool such as CSH as I presented. That is something I'd like to talk to you about for 10 minutes or so, if that's what we have.